Review worksheets, looking at number 8. Given that the secant is 5/3, secant goes with cosine, so a over h does not terminate in quadrant 2, which of the following must be true? Okay, not in quadrant 2. Where is the secant negative? But that also means where is cosine negative? Let's see. Cosine's negative over there on the left. In 2 and 3. But this one's not in quadrant 2. So the only option left is quadrant 3. Because if cosine is negative, it's got to be in 2 or 3, but it's not in 2. Whoops, I wrote that wrong. Hypotenuse over adjacent. Hypotenuse is 5, adjacent is 3. Where did that negative come from? The 5 or the 3? The 3. Is this a famous right triangle? 3, 4, 5. Yes. So my missing side is 4. Yes or no? Yeah. Yes and no. Negative 4 would be the better answer. All right. Sine of 2x is 2 sine x cosine x. The sine of the angle is opposite over hypotenuse. Cosine of the angle is adjacent over hypotenuse. And then do we know how to multiply fractions? I hope so. Multiply across. 2 times 4 is 8, times 3 is 24. 5 times 5 is 25. But that says negative, so number 1 is a no, not true. Cosine 2x is cosine squared minus sine squared of x. Cosine is negative 3/5. Sine is negative 4/5. So that's 9/25 minus 16/25 would be negative 7/25, which is correct. I wonder if we can get it by just knowing those. So 1 is out, 2 is true, 1 is out, 1 is out. So we're down to B and D. We got to figure out if 3 is true or not. But tangent is sine over cosine. So 24 over 25 over negative 7 over 25. Keep it, change it, flip it. Multiply top and bottom by 25. Or you've seen this problem so much that you know what the answer is. Negative 24 over 7. So 2 and 3. Yeah, that was a good one because that had secant, had the not terminate quadrant thing, and then we had to work all 3 double angle questions.
Thank you.
Number 3, using a sum or difference identity. Well, to get to pi over 12, I think it's going to have to be a difference. So I want to subtract things to land at 1/12. But I need them both to reduce, right? So I can't use 5/12 or 1/12 or 7/12. So I could do 4 and 3. That would work. There's probably more than one way to get there. But that will work. 4 minus 3 is 1. And they both reduce to unit circle things. So sine of the first one, cosine of the second one, minus cosine of the first one, sine of the second. Again, that's the formula. So you could write out the formula, or you could just kind of match up the pieces as you go. Let's see, sine of pi over 3. That would be root 3 over 2.
Hello, is Jesus here?
Sine of pi over 3 is root 3 over 2. Cosine of pi over 4 is root 2 over 2. Cosine of pi over 3 is 1/2. Sine of pi over 4 is root 2 over 2. The vast majority of you know your unit circle, so you're fine, but if you didn't know your unit circle, you would be stuck. So root 6 minus root 2 over 4. Okay, they all look the same. I better be very careful about signs here. A, root 6 minus root 2 over 4. Number 15. Sine of x equals 12/13, and x is between pi over 2 and pi. So that's second quadrant. Opposite over hypotenuse. Is that a famous triangle? Famous enough for you to know the missing side anyway? And you're going to miss something if you go with that as your answer. Negative. So, I mean, it's subtle, but you got to be always on guard for when you draw the pictures. Make sure you are careful about who's negative. All right, so x is in quadrant 2. That means x over 2 is in quadrant. Remember, this is where you could divide all of that by 2. Or you could just divide the quadrant number in half. And we're in quadrant 1. Who's positive in quadrant 1? All of them. So I can kind of go through and mark out any negative answers. Well, I didn't mark out a lot, but everything's positive in quadrant 1. All right, sine of x over 2 is plus or minus 1 minus cosine of x over 2. Now, we already said we're picking the positive one, so I don't really need to write the negative thing anymore. Cosine is negative 5/13 all over 2. Okay, how do you want to clear up this fraction? Some of you check out on the problem and you're like, oh, I got it from here, but you may not. How do I clear out that 13? I want the 13s to cancel, so let's multiply by the 13. This is still all under the radical, so 13 plus 5 all over 26. So that would be 18 over 26, which is 9 over 13. This seems to always work out where the top has a square root. So 3 root 13 over 13. This is what has me worried about tomorrow's test. I'm not worried that you can draw the pictures. Careful with the negative sign. It's once you have your first step of your answer, can you algebra your way neatly, correctly, carefully to the final answer? Let's do the cosine one. 1 plus cosine of x over 2. 1 plus Negative 5/13 over 2. Again, we'll multiply by 13 to clear out the fraction. So 13 minus 5 all over 26. See, 8 over 26 would reduce to 4 over 13. Whoops. So that's 2 over square root of 13. So A, 2 root 13 over 13. And then tangent, I have two options. I can do 1 minus cosine over sine, but I can also just do sine over cosine, especially since I have them already. It looks terrible, but keep it, change it, flip it, or be careful with crossing out, and you get 3/2. Again, if you're not comfortable crossing things out, then take the safe route. Keep it, change it, flip it, and you get 3/2. Number 6, given sine of A equals 3/5, A is between 0 and pi over 2. So that's first quadrant. Opposite over hypotenuse. Missing side is 4. And since there's two triangles here, I better label that A so I don't get mixed up later. B is between pi over 2 and pi, so that would be second quadrant. Opposite over hypotenuse. What's the missing side for triangle B? Good. Negative 12. 5, 12, 13, but 12 is negative. Now, the test is like this as well, where there's some setup and then several problems to follow. So we need to pause here and make sure our setup is right. Right? Because if I forget that negative on that 12, then I'm probably going to miss them all. And maybe I'll be kind and try to figure that out and be generous with partial credit. But it'd be better if you took a minute to double check to make sure your pictures are right so that we can get on with this problem. Let's see. Do I want to do all of these? I did a difference earlier. Let's do the two sum problems. Sine of A plus B is sine of A cosine B plus cosine A sine of B. And if you tell me that the sine of A is the sine of 3/5, I'm going to throw something at you. At least in my mind, anyway. What's the sine of A equal to? Now you're scared because you don't want me to throw something at you. 3/5. Not the sine of 3/5. The sine is equal to 3/5. People say throw an eraser, but the only eraser I have is like this big guy, so I probably should not throw that at anybody. Get in trouble.
I think scissors.
Scissors, great idea. Cosine of B, adjacent over hypotenuse, negative 12/13. Cosine of A, 4/5. Sine of B, 5/13. So, let's see, 3 times 12, that's the easy one. Negative 36 over 65 plus 20 over 65. Convenient that they already have a common denominator for us. So negative 16 over 65. Cosine of A plus B is cosine A cosine B minus sine A sine B. Again, that's on the formula chart that you can look at. What's the cosine of A? Ryan, what's the cosine of A? It's not on that picture. Cosine of A?
Yeah, oh, the cosine thing. 3/5.
Did you say that wrong on purpose?
4/5.
4/5. 4/5, not the cosine of 4/5. The cosine is equal to 4/5. The cosine of B is negative 12/13. The sine of A is 3/5. And the sine of B is 5/13. SOHCAHTOA, 4 times in a row there. So negative 48 over 65 minus 15 over 65. That would be negative 63 over 65. Which is answer choice A. A lot of times you end up with a common denominator, so at least you don't have to worry about that.